All right, so 2.8, I'm pretty sure this is something that you would have seen in Algebra 1. I'm like about 99% positive that you did. At least if you did take the class here. If you didn't take it here, then maybe not, but I still think that's something you've probably seen before. So 2.8, graph linear inequalities in two variables. All right, so a linear inequality in two variables, it can be written in one of four ways. AX plus BY is less than C. AX plus BY is less than or equal to C. AX plus BY is greater than C, or AX plus BY is greater than or equal to C. Okay, and we graph these just like we do something in slope-intercept form. We would get y by itself, and we would graph it that way. But the difference is that when graphing it, okay, if it is just less than, just do it this way. Okay, if it's less than or greater than, then we have a dotted line. Less than or equal to or greater than or equal to, we have a solid line. Okay, and we shade in the direction that it's facing. Okay, so remember that inequalities have shading. So we shade in the direction of the sign. Okay, so example, y is less than 3x. Okay, then this looks something like okay, I have a y-intercept of 0, up 1, 2, 3 over 1. Okay, this is just less than, so it's a dotted line. Okay, and it's where y is smaller than everything else, which means I would shade down here. Okay, so you may want to have other colors to do that with. Just be careful, because if you shade with pins and then you realize you're wrong, you're going to need to redo the problem. Okay, so make sure you're really sure about it before you start shading stuff. Outside of that, another thing that we would be doing is deciding if the ordered pair is a solution to the inequality. Basically, we would just be plugging in the ordered pair and solving for the variable, and seeing if it is true. So if I had so is the ordered pair a solution? So like 4, y is less than or equal to negative 5x, and we're given the two ordered pairs 3 and 2, and negative 2, 1. Okay, these are two different problems, technically speaking. Okay, so I just plug them in. So 2 is less than or equal to negative 5 times 3, and you do need to show this step of plugging them in. Okay, 2 is less than or equal to negative 15, so that one is not a solution. Okay, so 3 over 2 is not a solution. But over here, 1 is less than or equal to negative 5 times negative 2. 1 is less than or equal to 10. So it is a solution. So negative 2, 1 is a solution. Okay, so you need to show it like that. For the most part, that's all we're really doing with this section. We're not going to be graphing like the absolute value inequalities and stuff like that. I'm not worried about those. We're just going to be doing this basic type here, just kind of as a refresher from Algebra 1, and that's going to be all for that section. So I know this is really short, and we just probably will only need to do a couple examples in class, so this shouldn't be a long section or anything. But that's it.